This is the second part of the video showing to build 12V DT to 220V AC inverter using TL494 PWM controller. Here I am adding ground connection to the common source of the push-pull MOSFET based power stage. Now I will add 10 kΩ pull-down resistor to the gates of each IRFZ44N MOSFETs. Let me rename the resistor so that it is consistent on the schematic. Let's continue to add the pull-down resistors. The pull-down resistors serve as a safety mechanism to ensure the MOSFETs remain in a known off state when the TL494 or driver stage is inactive. By referencing the gate to ground, they bleed off any leakage current or stray static charge that could prematurely trigger the gate. This prevents unintended conduction during circuit power-up, high impedance states, or if the driver connection is lost, effectively protecting the inverter from erratic behavior or catastrophic short circuits. Next, I will add gate discharge diodes across each gate resistors. The 1N4148 diodes function as a high-speed bypass for the gate resistors, enabling asymmetrical switching for the IRFZ44N MOSFETs. While the resistors limit the turn-on current to minimize EMI and ringing, the diodes provide a low impedance path to rapidly evacuate stored gate charge during the turn-off cycle. This accelerated discharge ensures a crisp transition to the off state, which is critical in push-pull topologies to prevent shoot-through, a condition where both sides of the transformer conduct simultaneously, thereby reducing switching losses and protecting the power stage from thermal failure. That's it, the circuit is complete. Now it is ready for simulation. The link to the first part of the video, where I've shown how I made the rest of the circuit, is provided below. The next part of the video is also provided below. The next part will show simulation of the circuit that demonstrates how the circuit operates. It also shows input voltage from 12V lead-acid battery, 220V bulb with the output, measured output voltage, a signal waveform of the output, and the frequency of the output signal produced. Thanks for watching.